In this mini lecture, we're just going to do the one-factor analysis of variance test, similar to the one that we did in class today, which was October 24th. And here we have 4 brands of automobiles: Taurus, Chevelle, Infiniti, and Sierra. And and we're interested in whether the average gas mileage across these 4 cars is equal to or different from one another. So obviously, since there's more than 2 groups here, we can't run a 2-group difference of means test. So ANOVA is the logical test for us to run. Notice here we've got group means that give us some guidance. Seems to me that the Taurus and the Chevelle get about the same mileage. The Sierra appears to get quite a bit more mileage than the Taurus and the Chevelle. I don't know about the Infiniti. I don't know. That might be that. I don't know. We'll just have to run the ANOVA test and find out what happens to that. Okay? So to run the ANOVA, we first click on add-ins, and then we drag over to Megastat. And then we drag down to analysis of variance. And for the time being, we only work with one-factor ANOVA. So what you'll see here is that running the ANOVA in Megastat is really very easy. It just asks for the input range. Notice that I highlight the column headings and all of the data. So even though some of the vehicles have more elements than others, or some of the brands have more elements than others, we still highlight the entire grid. Okay, I didn't include my descriptive statistics, but I went down as far as all of the elements in each sample are concerned. And we'll ask for post hoc analysis. It says here when P is less than 0.05, yes, because that's our critical value. And then we'll look for a plot of the data. That might be good for us to look at. Okay, we're not going to ask for display partitioning. So we click on OK. And here's our results. Here's our descriptive statistics for each of the cars in our sample, as well as this 33.6. Let me try to make this a little bit bigger if I can here. So 33.6 is our grand mean, and then the 29, 27.8, and so forth, those are our group means. At this point in the semester, we're not concerned with anything in the ANOVA table except for the p-value. And you see here that the p-value is 0.02, which is less than our critical p-value of 0.05. So we reject the null hypothesis. In other words, we conclude that not all of these vehicles gets the same average fuel mileage. But now our question becomes, okay, so they're not all equal, which ones differ? And that's where we go down here to the t-table, to the p-table. And if you'll recall, this p-value corresponds to if we had run a difference of means test between the Chevelle and the Taurus, we would have gotten a p-value of 0.78, which means we don't reject our null hypothesis. Well, if you look here, the Chevelle and the Taurus got just about the same mileage. 29 miles for the Taurus versus 27.8 for the Chevelle. This p-value of 0.15 between the Chevelle and the Infiniti got 34 miles, and the Chevelle got 27.8 miles to the gallon. So those are getting pretty far apart, but you can see here that with a p-value of 0.15, we would fail to reject the null hypothesis. Now, if we had a larger sample, in other words, if we would have had a sample even in, let's say, the 15 or 20 range, there's a good chance that this p-value of 0.15, there's a good chance that p-value would have been less than 0.05. Now, if you look at this p-value of 0.0069 between the Chevelle and the Sierra, we're not surprised at that because the Chevelle only got 27.8. That was the lowest average mile per vehicle, and the Sierra got 40.8. You'll also see that the Sierra was statistically significantly different from the 40.8 versus 27.8. but it was not statistically significantly different from the Infinity, because those two vehicles got 40.8 and 34. And if you'll recall earlier, I said I just wasn't sure how that would work out. But again, if we had even a slightly larger sample size, again 15 to 20, in all probability this p-value would have been less than 0.05. So we know how to write our null hypothesis. All the group means are equal. We know how to write our alternative hypothesis. It can only be written in the two-tail sense, in that not all of the group means are equal. We read our p-value to decide what to do in terms of rejecting or failing to reject the null hypothesis. And then what really becomes key for us here is to learn how to read this table. This is where we go from mere statistical correctness to managerial insight or pragmatic managerial feedback. Now, you can also see here, in terms of the Taurus, the Chevelle, the Infinity, and the Sierra, you can see each of these little diamonds represents the average mileage for a vehicle. So one of the cars, one of the Tauruses got less than 25 miles to the gallon. One of the Tauruses actually got more than the group mean. It got about 35 or 36 miles to the gallon. But the overall group mean was just under 30 miles for the Taurus. And you can see here for the Sierra, one of the vehicles got nearly 60 miles to the gallon, and one of the vehicles got only about 30 miles to the gallon, whereas the group mean was just under 45. If one of these vehicles had no within group variance, okay, if one of these vehicles had no within group variance, all of these little diamonds and the bar for that column would all be affixed together, okay? But because you can see here how variability the data are for each of the vehicles based on the dispersion or the spread of the diamonds. So you've got more variability on the Sierra than you do the other vehicles, but all the vehicles have some dispersion. Okay? So that's ANOVA, how to interpret the null and the alternative hypothesis, and how to bring in managerial insight by looking at the post hoc analysis.